How are you doing? My name is Lars Christensen, and this is the 12th episode of Ask LarsLive. This is where I jump through a bunch of my emails for the next hour or so, just trying to add some Fusion 360 value to you. Hopefully. That's what I hope. Thumbs up if you like it, thumbs down if you don't. That's okay. Love the comments. And if you have not subscribed to the channel, I would truly appreciate if you do that. It would mean the world to me. I know many of you guys have, but if you haven't, please. Let's get into this. First one is from Marty. Lars, I'm not sure where to get help for this. Could you maybe help? Question mark. I don't know, Marty. My computer just went through a Windows 10 update. Ooh, and I cannot get Fusion 360 to start, regardless of the icon I click on. Help! Question mark, question mark, question mark. Thank you, Marty. All right. I don't know exactly how much I can help you. I know I'm not the greatest computer person, but there is a lot of ones and zeros in there in your computer working all together. Here's what I would do. I would jump to Google, and in Google, if you go and you search Autodesk Knowledge Network, that is a great place to start. If you search that, you will get to this Knowledge Network page. It's one of my favorites. And in here, you can actually choose what kind of software you want of Autodesk software you want it to search for. I would do something like a clean uninstall, install or uninstall information. Click on that. And in here, there is a couple of different articles about this. So how to perform a clean uninstall. That is probably what I would recommend that you do. Follow these instructions, and that should take you through how to clean everything out for Fusion 360. Then just go ahead and download it again and reinstall. So if you go to Fusion 360, download again the trial, you get to type in your Autodesk ID, what is just your email address and your password, and then you should be all set and back up going. That would be my first recommendation. All right, that was a quick answer to Marty. I hope that was useful. Thumbs up, thumbs down, whatever, whatever you feel like. It's all good. Let's jump into the next one. The next one is from Michael. Hi, Lars. Thanks a lot for your awesome Fusion 360 videos. You're so very welcome, Michael. I basically learned everything I know about CAD from you. Haha, I'm just happy to help. One suggestion for a future topic, if I may. Yes, you may. I'm currently designing parts for a quadcopter, and hence I'm very concerned with everything being as lightweight as possible, yet structurally stiff and tough. Maybe you could make a video about how to do this with things like ribs, honeycombs, and other tricks. I've already watched your videos about simulation. That's great. All right, thank you, Michael. Yes. Let's talk a little bit about this. So I think that there's a couple of good things in this, and we'll jump into Fusion. I'll show you actually a pretty neat tool about this. So first of all, I don't know that much about flying things and quadcopters, so take anything I'm going to say here with a little bit of a grain of salt. But there is some pretty neat tools inside of Fusion for this kind of lightweighting or structural things. Now, when it comes to ribs and honeycombs, there is some different tools you can use. So let's jump into Fusion. That's where we want to be anyways. There is some tools in here that you can use. For example, there's the web tools and things like that you could play around with. And then, of course, you could go into the simulation space like you talked about and kind of verifying that whatever you did with these web tools, or if you model up like honeycombs and things like that, how they're going to stand up. But funny enough, there is a channel you should know about, Thomas Sandlander. I think maybe Thomas is Swedish. I'm not sure. You guys maybe already know about Thomas. But Thomas just actually released a video one day ago talking about topology optimization. And I have done a video on topology optimization a while back. But you should definitely go and check out Thomas's. You should also subscribe to Thomas if you have not already. I love his videos. He gets into to some 3D printing. We're going to talk about that later too. So you should definitely check Thomas's channel out and check that video out on topology optimization. But talking about quadcopters, let's jump in and try to talk a little bit about this topology optimization, or as it's also called, shape optimization, because you might find that interesting, Michael. So what I'm going to do is I'm going to model up a quadcopter. And no, not really, but I'm going to, because you know me probably, but I'm going to give you, I hope, I'm going to give you some hints on what we could do with something like this that maybe will give you an idea to get going. So I'm just going to model this up here, and D for dimensions. I'm drawing up some shapes as you already now have seen. Let's make this like 120 maybe, quadcopter like this. And I am going to go ahead and use a circular sketch pattern. So we're going to select this circle here, and we're going to spin it around here, and we're going to make 4 of them. So now we kind of like have 4 circles inside of Fusion. So this is going to be the main body of your quadcopter, and this is going to be where I'm assuming you're going to attach your rotary blades, or whatever those are called. And I'm going to go ahead, I'm going to extrude this out. I'm going to extrude them all to the same thickness. I'm going to use, I'm going to go symmetrical. So I'm going kind of like both sides, and let's just make sure that we know how thick we're going to make those. So we kind of have the body, and then we have these 4 things here. Now, I'm going to connect them all. So I'm going to open up a new sketch. I'm going to also again sketch on the top plane. I'm using Symmetry here, what is something that I always find good and interesting. So I'm just going to, actually, let me do a center rectangle, S, and do a center rectangle. And I'm going to make this, I don't know, 230 long. Oops, no. Wow. I'm in the wrong box here. Let's make it 15 tab and then 230. Like that, hit enter, and let's extrude that. So let's take that rectangle, we're going to make that also symmetrical, and that just means that it's kind of doing it over the middle. Now this is going to be a cut, so I'm just going to go ahead in here, and I'm actually going to make it a join. So it's going to join these 3 pieces together that it's intersecting like that. And since we used a sketch to rotate the circles, we could go down and use a solid circular pattern here. I'm going to change this to features and select that feature here and rotate around this axis. So before, if you go back, make that 4, and let's just do that there. So before, when I did the circles, you saw that I used this inside of the sketch, I rotated it. Now we actually did it as a solid. I'm just showing you a couple of different ways to do this. You will see, though, when I go over to the bodies folder, that the first body did manage to become one solid, but the last 2 pieces here are sitting out here as their own bodies. So I'm just going to do a quick combine and just select all of them over here and combine them all into one body. Okay, here we kind of like have our quadcopter type of solid. I hope you can follow me this far. If it goes too fast, just rewatch it, slow down. Let's go over to simulation space. Now, simulation space, we normally utilizing this to check that the part is going to withstand what we have modeled up. But as you guys are familiar with, we have some different tools inside of Fusion where we can actually utilize simulation tools to generate a shape. One of them is generative design. And I've talked about that on this channel before. That only comes in the paid version. And it also costs some money, and it can take into different materials and things like that. But what Thomas did the other day, and what I want to make sure that I'm using for this too, because I think Michael can find that useful, is, if you go into the simulation space, is to use this shape optimization. It's doing the same thing as generative design in a sense that we're utilizing loads and constraints to come up with a shape. This is just not as advanced as generative design, but it's a good starting point, especially if you are a hobbyist or things like that. So I'm going to say I'm going to create a new study in the shape optimization workspace. And the easiest thing in here is just to kind of like just slow down, be aware of that over here. Keep an eye on this little pre-checker here. That will give you kind of an indication of how you're doing, because there can be a lot of settings. But I'm going to try to send you through this, Michael, and give you some hints. First of all, I like to work out of this tree over here a little bit. So if you're looking over here, you will see that there's starting material. If we click on the little pencil, it will let us edit this. Now, I don't know what your quadcopter is going to be made out of, but know that you can change different materials in here. So I'm just going to select a aluminum 6061 just to select something different than the default steel. So you know that is happening in here. Now then, so that's kind of like up here. The next thing you got to do is give it constraints. So right now this model is kind of like floating out in space. We got to kind of like tie it down. And we're going to do that by adding a constraint. I am going to add a constraint by fixing the backside here. And that means that would almost be like if we glued this to a pole or something. And then the next tab you will see here is the load. So I'm going to apply a load to it. And I'm actually going to apply a load to this face, this face, this face, and this face. Now be aware of that shape optimization is not utilizing loads in the sense of a static stress analysis. And I'm going to try to say this without making it too complicated. But pretty much what it means is that whatever load you're putting over here, and right now it's Newton, I actually like to do that into pounds because that makes more sense to me. That whatever number you're putting in here is not really going to change what we're going to get out of shape optimization. So I'm putting in 350 pounds, but you could put 500 pounds and it will not change really what we're getting out of it. But so we're putting loads here. I hope most people can follow me so far. Now we can go ahead now and you will see that we're actually getting a pre-check. And we can go in and click solve for this right now. Now, I have to admit that I'm 100% sure about this. I'm pretty sure, I'm 99% sure, I should probably check this out, that you will see if you're on a hobbyist license, they will say this is going to cost you 0 cloud credits. Because I'm kind of like, I work for Autodesk and I'm on a bought license, it's going to cost me 5 cloud credits. That's equal to $5. $5 is probably not too much. But I'm going to go ahead here and click solve, and it's going to ask me to save this. So I'm going to save this as Michael's file and click save. Now when I do this, it's going to now start solving this part. And it's just going to take, it's not going to take very long. It's just going to send it up in the cloud, and it's going to do a quick solve on our part here. And while that is happening, I'll leave it on the screen. I'm going to take a sip of my coffee. Because this is just me trying to add some value to your Fusion 360 experience. And just hopefully you find this kind of stuff useful. So I'm just going to give it a minute as it's solving here on the cloud. So now I could start a conversation with some of you guys about, so how is everything going? What do you think of the Yankees? But I don't really have much to that. While this is solving, I can tell you that next week we have the Fusion Academy out in Portland, and I will be there. So hopefully you are going to join me out there. I'm actually going to just close this down for a second because I wanted to show you that you can actually see that over here it gives you a solving in process. So next week, that will be August 6th, I believe. There is the Fusion Academy out in Portland, and I will be out there. There we go. That's solved. All right. I just had to fill in the space here. Now, we get a result here, and you get kind of like a thing you can pull in over here. So if I pull this all the way down to the end, we will kind of see our model, and then you will see as I'm dragging up that things start to disappear. But this is not, Michael is looking at this right now. Michael's like, this is not really helpful. I'm not quite sure what I'm looking at. So let me just show you why that is. That is actually, if I go over and I turn on this light bulb that says mesh, you will see that we get a mesh appearing right here. And without getting too much into detail, this is a very rough mesh, very big triangles. And that is why that when I pull this slider up here, this looks weird. Like it doesn't give me a great result. But I wanted you to know that. So what I'm going to do is I'm actually going to run the study one more time. I'm going to right click up here and I'm going to say clone the study. Clone the study gives me study number 2. So I pretty much just took the original study that we just ran and I'm just going to copy it again. Now I'm going to go in and edit the mesh. And if I go down, so what I did was, sorry, I went a little fast. I'm going to click on the pencil and I'm going to switch to absolute size. And I'm going to make this 10 might actually be good right now. I'm going to hit OK for 10. And then I'm going to right click and say generate a mesh. So that means that the model is going to be regenerated. And now you will actually see that instead of before we had 2 rectangles, now we have, it's broken up in multiple rectangles. Let me go back to the first study. You can see how big it is here. Let's go down to study optimization number 2. Now it's like this. You could decide to be more accurate, and we could clone that one more time to number 3, and we could actually maybe go in and make it half that size. Now, knowing that the lighter you're doing the mesh, the longer it's going to take to solve, but it will give you better results. Okay, so I'm going to go ahead here. I still have the green check mark. I'm going to go ahead and start solving this study right here with define a mesh. Now again, it's going to take a little time, a little bit longer to do this because this is this now have a finer mesh on it. But I'm trying to let you know as many things as I can without going too much into depth for this. As this is going, I also want you to know that there is something up here called shape optimization. And what you can do in here, if you just clone this study one more time, clone this study into a study number 4, and you can work with that while it's solving up here, that you do have some shape optimization tools. What this will let us do is it will actually let us tell the software certain areas where we don't maybe want it to build anything. So you can actually go out here and select different regions. So maybe I don't want certain areas where I'm going to mount the propellers to be involved with this. Maybe it's more out here on the main body where maybe the engine's going to be for this thing here, where you could kind of tell an area where you're going to tell it that there's not going to be any, don't mess with this area here, and you're kind of like preserving that area. That's the shape optimization out there. So be aware of, you have a lot of different options in here. There is also a lot of different videos out online about this. So I don't want to get too far into that. But let's just jump back to our third option here, what was the one we just created. And let's look at this result. So now, Michael, you will see that because we made the mesh clearer, we actually are getting a different result. And what you can do here is we can kind of scroll this one up and down. You get an idea about where you maybe could remove material. So if I move this one up here, you will see that clearly where we're going to mount our propellers, that we could actually maybe clear some things out there. You'll also see the center, and that's probably going to be cleared out anyways because we're going to have our electronic things. But you will also see that we get some pocketing in here where we maybe could, like you had talked about, putting some honeycombs or some ribs. So this is pretty neat tool to kind of give you this kind of idea about this. And what is really cool about this, to wrap this up, is that if I go to the results section up here, you can actually promote what we're seeing on the screen, if I click on this promote button, and I can go over here and I can say to the model workspace and hit OK. And now I'm back in my workspace, and look what I got. I got it out as a mesh. And if you worked in watched my videos before, you now know how you could possibly convert this into a solid, or you could of course also just start sketching, using it as a reference and model things away. But Michael, this was a little bit of a long video, but hopefully this was something new that you could find useful for this. So that was super helpful. Thank you so much, Michael. Hope that was good. Hope that gives you new ideas to how to design your quadcopters. Thumbs down if this was stupid. Comments as always. And if you haven't subscribed, I would appreciate if you do that. That just kind of like, you know, that's my fuel. Your comments and subscriptions is kind of what keeps us YouTubers want to keep on doing this on our weekends. Next one is from Eddie. Eddie says, hello, Lars. Thank you for your YouTube videos. You're so very welcome. They've helped me tremendously. Lately, I've been trying to figure out boundary fill. This is a good one. And calculating the volume, as it would be a great tool for me designing speakers. Ooh, that's kind of cool. Watch some different of your videos. Going on. Anyways, wondering if you could touch on the subject. Let's do it right now. So, this was Michael's quadcopter using topology optimization. Don't forget to go and subscribe to Thomas's channel. He's super cool. Love what he's doing over his channel. A lot of 3D printing if you're into that. Now, this one for Eddie. I'm starting a new file here, and let's design a speaker. What do I know about speakers? Let's go ahead here and S key. It's going to give me a center rectangle. And I don't know how big speakers you are doing. Eddie, probably bigger than these ones. But anyways, let's go ahead here and make some kind of a speaker housing. 400 thick. I'm going to use this shell command. Boom. That will kind of give me the speaker wall. Let's make it 15. And then open up sketch on the side here, C for circle, and I'm just going to draw up the base and a treble. Now I'm going to use the constraint to make this one and this one vertical, and this one and this one vertical. D for dimension, let's give it a dimension here, 175 for that one, and 60 for that one. I don't know what is the right numbers, but what you will see here, I think, is going to be a pretty neat trick. There we go. Q for press pull, and that's just cut through there. There is my speaker housing. So what Eddie would like to know is the volume. And I don't know too much about sound and stuff like that, but I'm assuming that if you're building a speaker housing, like this cool one that I'm modeling on right now, that you need to know the volume within it, right? So you can figure out what size speaker holes maybe. Somebody leave a comment. I would love to know more about that. Eddie or somebody else who knows about this, let me know. Now let me show you how boundary fill that is sitting under here, create, how we can use this. So we need to close off our speaker housing. And you can do that a couple of different ways. You can actually use planes, but I'm going to use kind of like probably what you want to use. Eddie, what is the surface command? And I am going to hit the patch tool, and I'm literally just going to snap a lid up here by clicking on the inside edges here, and that will give me a patch surface. Now a patch surface, if I select this inside of here, right click, repeat patch, is paper thin wall. Like right now, this thing is still hollow. So if I just do this here, and let's do a section analysis, you will see that this thing is still hollow. But what we just did was we kind of like closed it off with very thin, non-thick surfaces. So we need to make it enclosed, and the boundary fill is actually also right in here. If we go to create, you will see the boundary fill is also sitting in here. What this will let us do is we are going to select the tools, and the tools is actually all the stuff we just created. So the extrude of the housing, and then these 3 lids. When we do that, then we can select the cell over here, and we can select one of these 2s. Now it gives us 2 because it could actually create an internal volume and a volume that is the same as the outside here that we did originally. And sometimes it's just, you don't really know which one to pick. I'm going to select this one here and see if I get the right one. I'm going to hit OK. And I get an extra body when I do that. Let me just turn these ones off. And you will see that that was the right one. What I got is something that filled up that speaker housing, a solid that filled up in that speaker housing. Now, some people's gonna tell me right now, well, dummy, you could just have done a extrusion from this body and filled it up. Yes, but that will not use boundary fill, and it's just not that cool. It's still the same, I know. But what we're looking for is kind of filling up that space. Now, if I selected the wrong triangle before, I would just have gone down, right-clicked on the boundary fill, and I would have unchecked that one and selected that one instead. But I did select the right one first time. Now, what I can do, let me turn off the main body. Now, when I got this filler here, I can right-click on it, and I can say Properties, and there you have it. There's the volume of that. Now, if you're working in Imperial, if you're in America, Eddie, then you probably don't want it here in metric. Then just switch your units, and it should switch over. So, speaker box, inside volume of your speaker box, you get that with the boundary fill. Eddie, I hope that you found that little trick useful. I love the boundary fill. I don't use it enough. You can do all kinds of cool things with the boundary fill tool. If you like this, thumbs up. If you don't, thumbs down. And give me some technical details on this whole volume and why it's so important when you're making speakers. And if you haven't already subscribed to the channel, it would mean the world to me if you would. Thank you so much. All right, let's jump on. Jump on to the next one. This one is from Jaden. Jaden is being persistent. He emailed me this a couple of times. I will show it this time around. Jaden says, and this is a good one. I've actually wanted to show this one in a long time. So thank you, Jaden. Hello, Lars. Is it possible to download materials for appearances command that is not already listed in the browser? What Jaden is talking about is, if we go back over here to the speaker that we just created the volume, but I created kind of like a speaker case here. And let's just jump over to our normal solid environment. If you hit A on your keyboard, A for Apple or appearances, you get this appearances catalog. What Jaden is asking is, can you download different materials in here? And so there's different materials already in here. Click on fabric, and we can see that there's some different fabrics. And you can, of course, just up here, you can choose if you're going to do it on a face or body. I'm just going to select face, and let's take a light brown fabric, drag that over there, and you will see that we get a kind of fabric looking appearance. Now, before I get into Jaden's too much, you should know about this because this is kind of magic. If you right click on this, you can edit it and you can actually play with it. So you can scale that fabric up and down. You can rotate it if you wanted some kind of angle, change roughness. And if you hit advanced, you will actually see that it kind of appears in here with a different image. And I'm going to come back to this just in a second. Now, if you scroll down here, you'll see there's many different ones in here, including metal, liquids, and for example, paint. You'll see me using something like glossy paint many times. drag a green over on that face. And let's just add one more. You will see that there is stone, roofing, woods. There's a lot of woods in here. We can go in and see that there's some different types in here. Now, anytime that you see that there's an arrow, that means that these can be downloaded. So they were not installed with Fusion, but if you click on them, then 3, 2, 1, boom, they're installed. And if I drag this over, we now have a particle board on the back. And of course, this is where, again, like I just showed, if you right click and hit edit, that it's nice that you can scale it, because you know, this may be if you have a big table or something like that. So that's extremely useful. All this stuff I'm showing to you here, of course, is cool for the model here, but it really becomes prone when you get into the render environment. And we've been in the render environment before. It slows down my recording, so I'm not going to go in there right now. I have videos on it. I'm not going to go into that. Now let's get to Jaden's question. Can you download more materials in here? Not as far as I know, but that should always be a but. I actually think that we can do something that is a little bit cooler than just download some materials. There is probably materials out there that you can download in there because it is customizable. Let me show you what I'm talking about. So, and this is something, like I said, most of the times we're talking about appearances. When you see it in CAD software, it is to get it into the rendering environment where we can make realistic renderings of our designs, right? So what happens, Autodesk have other softwares for this, like RAD or VRAD and other programs. But what you can actually do is you can create your own materials in here, and that's when things becomes really cool. So what I did, I was looking around my house for a material that I thought could be interesting. So you could also, of course, just go out on Google and you could find different material. This was a picture I took of my guitar case. I hope somebody have noticed that I'm wearing, maybe not wearing my PRS t-shirt today. So I took a picture of a guitar. I was looking for something interesting. I think that's my head shadow, you can see right there. But what we can do in here that is super cool is with this, and this is actually what the pro renders do. Many times they will go out and find an image and they maybe go into Photoshop, change it, cut things out, whatever they want. And then we could go in here, for example, we saw that before. If we took this fabric, if you right click and hit edit, and we go into advanced and we click on this image, we can actually change the source for this image. So if I click on this, you will see that now I can go to my download and I can find that image of that appearance. And you can do all different kinds of things in here. Set it up, scale it, whatever you want. And now you will see that it has actually done that. Now you will see that it did it as all different kinds of squares. So maybe I do need to go in and do some adjustments in here in regards to scaling it up. So you can start scaling it. We could probably actually also just go in here. Let's see. So we have that. Close that out. Oh, it didn't stick. Let's go in and do that again. Advanced. It didn't stick. Select that. Open the file. I was thinking if there's something in there where I can do it a little quicker than starting to put numbers in. Cut out. Translucency. Alright, let's try to see here. What happens if we make this 500? Maybe that was too big, huh? $500 millimeters. Oh yeah, now we're getting somewhere. 500 by 500 as a scale. Start looking interesting. 250. Right? So now we start seeing that appearance happening in here. So we could just play with it until we get something that we are happy with. 100. No, it's got to be bigger than that. 200. Okay, and then we can offset it. We can do different things. But this is how you can do this. We can hit apply to that. Now it's going to stick. And then know that if you right click here, you can now say that you want to add this to your favorites. And if I click add it to my favorites, then over here in my favorites folder, that will appear over there. And now I have it. So whenever I want to add it to another side, I can add it to there and you can play with it. So that's one way that you can add different materials in here. Play around with it, adjust it, click on it, and you should be able to see that you can get some pretty cool materials and appearances in there. You can completely make your own. Hope that was useful, Jaden. Glad that I finally got that one answered. All right. Thumbs up if you like it. Thumbs down if you don't. Leave the comments. Subscribe. Really appreciate you guys taking the time to watch these. What are we? We're about half an hour in, and so just trying to get through some of my emails, and hopefully you will find it useful. Next one is from Jim. Lars, I've been having problem using Canvas after I've stopped sketching. If I edit the sketch, I cannot use or find or open the canvas at the edit. You know what, Jim? I don't blame you for this one. This is like one of these silly things, I think. If we open up a new file, and we go and we say we're going to insert a canvas because we want to sketch something. So let's click insert a canvas. Let's select a plane to do it on, right? So we're all good with that. We're going to click to set in the canvas, and you actually see some of the next videos we're going to be doing. We're just going to select the image we just had, but it's not really useful. But go ahead here and we place it in here. You maybe move it around, you scale it, you can do all different kinds of things. If you're placing this image, hit OK, right? And now we maybe want to go in and start a sketch, and we can start sketching something, whatever we're doing. Now here's the trick. If you ever lose track of your canvas, it is sitting in its own folder up here, and that is sneaky because you're thinking that it sits within that sketch, but it's not. It is kind of sitting there by itself. It's sitting up there in a folder. Now, if you right click down here, you do have an option to go in and edit the feature, but I actually like to use this canvas folder better because that will also let you calibrate it in here. So this is where you can go ahead. If you wanted to calibrate it to a certain size, we can click here and go here and hit enter, and we'll calibrate our canvas to that. We can go in here, we can also hit edit, and we can go in and we can kind of play with the canvas, whatever we want. And you can of course also turn it on and off over here on this. So this is where it's hiding, Jim. Quick little good question. I can't tell you that I haven't been stuck there myself. Hope that was useful. Thumbs up, thumbs down, comments. I really appreciate it. Take care. Good, Jim. Next one is from Michelle. Michelle or Mikel? Michelle or Mikel, I'm not sure. Lars, just want to thank you for a great videos. Tried a lot of different CAD suites before Fusion, but it's best for me, especially with your videos. Well, thank you so much. This is a good one. Below is one of my first designs. It is a simple piggy bank that has a screw-on lid on it. Yes. So I'm going to highlight this one. Of course, hang on a second. Just bear with me. I did not get that link from this computer to this computer. So I wanted to highlight this one because I think that Mikel, depending on how to pronounce your name, they've done something that I absolutely love, and that is sharing the knowledge. You see my 3D printer is running right now. It didn't get done. It should have been done, but it ran out of materials. Typical printer issue. But what Mikhail did that I am a big fan of is that Mikhail didn't only just decided to model something up in Fusion, also decided to share it. So I think that is absolutely awesome. So here is the model that I am printing right now. If you go in and download the files, you will get it all. You will get the Fusion file, you will get the STL files, and all that good stuff. And I couldn't help myself, so I absolutely had to go ahead too and fire up the Ultimaker 5. And I am now printing my own piggy bank. And thanks to Mikhail's instructions, I'm actually printing it without support material, which is kind of cool that you put some information in there. Really appreciate you sharing it. That's on Thingiverse. I will make sure this link is in the description of this video as we're getting there. Thank you so much. Really appreciate it. Next one is from Paul. Dear Lars, thank you for mentioning my email in your Ask LarsLive episode 11. You're so very welcome. I'm sending files from Inventor and hoping they will work. Inventor file will work inside of Fusion. I've used Inventor for several years and can handle projects and file easily. Yep, but Fusion has me stumbled. Oh. I usually model in Inventor and import an IGES file to Fusion. You don't have to. You can actually just import your Inventor file directly in there. Actually, if you go out and and find a video did a few weeks ago called Get Your Fusion Team, you could actually go ahead and use Fusion Team, and you could literally just place your Inventor file in there, and you don't have to upload or anything like that. But we're not going to talk about that. What I need is a turn profile. This is Cam. And I haven't been able to get a good tool path or even generate a realistic tool without errors. I want to use a triangular insert on a tool oriented as for boring on an edge of the tool parallel to the C. Okay, so there's a lot of information here. I hope, Paul, that I can give you a couple of different pointers that can be useful. All right, let's start out by opening up your Inventor file. So you could actually just now, with the new function, you could just go and say, File, Open, and if you want to open from my computer, we could go out to our download folder, and there you will see I have a that IPT file. Click on that, and let's open that file up. All right, so this is going to be Cam, and I hope I can. There's a lot of functions on this part, but hopefully I can give you some tips and tricks to turning that you hopefully will find him. I'm not gonna wait for this to. I'm just gonna close and translating handlebar can't back. We are working on it. We'll let you know when it's ready, and you can check the status here. Got it. So that shouldn't take more than a couple of seconds. We're literally just translating our Inventor file up in the cloud. What gives me a chance to take a sip of water. All right, as I did that, did you just notice the upload progress bar just went back? It was up to here, and then it went back down. It always makes you wonder a little bit about what is going on behind closed doors. This shouldn't take more than just a couple of seconds to do this. We could also have used the upload button. That would have been another option. I just wanted to show that new function right there. All right, while this is happening, I'm not going to wait for this because we're already waiting for the quadcopter. Let's just let that happening in the background. And while that, we'll take the next question because the next question should be fairly quick. That is from Joe. Joe said, I have learned so much from watching your videos. Thank you, Joe. And got a question. I'm exporting my drawings to PDF. Everything looks great even when I copy and move the file between computers. The problem comes when I go to print the file and I'm left with line images of the part. And Joe actually sent me, that's still uploading, Joe actually sent me a couple of images. So let's just go ahead and look at those. Send me a couple of PDFs. Then we're going to open up the first PDFs here. And here we see the first thing. So this is a PDF when it gets printed out. And I do notice that it does get very dark looking. And I notice that you don't have, you're doing this with the colors on. There's another PDF that is worse. See this one here? You can kind of see shadows behind this. So when you're printing out drawings, if you want to have the colors on there, I'm wondering if that is what causing this, Joe. What I actually did was, I have to be honest, I did go out. Remember how we talked about earlier about the Knowledge Network, Google Autodesk Knowledge Network. I spent about 2 minutes searching on this to see if I could find a solution. I could not. That is probably my best answer to you, Joe, is to go out and try to search, see if you can find something here. This is definitely not acceptable. But like you said, it happens when you go to print it. So it doesn't appear on the screen within Fusion. So I think that there's something broken between creating the PDF, between Fusion and the PDF. And I don't know exactly what's up with that. You can also, another thing you can do is if you go and you search Fusion 360 support forum, you could also go and ask the question there and you might get a better answer. Sorry, Joe. I don't have the best answer for this one here. There we go. So let's open this file up. Pause. All right. So a lot of stuff going on with this part here for turning. And I'm not going to take you all the way through, but Paul, I hope really that I can show you a couple of tips to how to do this with the lathe tool. So I'm going to go into manufacture. And when we go in there, I'm going to click on a setup and make sure that you first select turning and mill turn. So make sure that that is. And then we could choose if we're going to do it like this in 2 operations. So maybe we do this operation first with the green chuck here in the back, and then we flip it over to the second side. So I'm going to show you a couple of different, what I think is a couple of different tricks. Now I'm going to hit OK to this. Just leave it at the default. And when we come to the turning tool, so you were talking about you always got arrows when you're trying to do turning tools in here, especially when you're trying to do special turning tools. What I would recommend you to do is start out doing a turning profile and just select a standard turning tool. And then work your way back. So if I go in here, for example, and I, select some kind of a turning tool, let's just select some kind of a, maybe a right-handed tool here, hit OK. So then we have the standard turning tool there. And then I'm actually just going to go in here and hit OK for right now and see what I get. So what we end up getting is the first tool path here. And you can, of course, go in and we can simulate it. Turn the stock on. And we can kind of see how it's doing this here. Now, a couple of things that I'm seeing already here that I don't like. I don't like this. See how it's machining down here? That shows some collisions in red. So let's just go back and edit that tool again. Be aware of that most of your options are right here up on front. So for example, that grooving you see is happening right here on this area here. So if I say don't allow grooving and hit OK, now it looks more like what I want. So it didn't gouge down here. So be aware of that you have these options. If I go back in and edit again, if you go to the geometry tab, you will see that I can control distances. So if I drag this back here and hit OK, now you will see that toolpath goes back there. You will see that it does do a last cut down to the center. If I go in and edit that on the front side, it says stock front. If I change that to model front, here. Now you will see that I'm eliminating that cut down. So be aware of that whenever you're working in here, it's all about starting out with a default tool and then start tweaking your things. And I know that this maybe sound a little crazy. That's how I do most of my cam. So get your toolpath closed. Now you were talking about your tool holder is really where you struggle, but I will take the same approach to my tool holder as you see that I'm doing on the toolpath. So I'm going to go in and right click and hit edit. And if I click on the tool, you will see this tool that we had selected here. And if I go in and edit that by right clicking on it, I can edit that tool, right? And you will see there's a general section. There is an insert section. So now you could go in and see that you said that you use a triangular tool, for example. So you can do that. You can mess around with all these radiuses. We could go in and say a holder. This is a turning general. Notice that there is a boring holder in here. We can change that. So now it's a boring holder. You talked about that was what we're using. And now if I just hit OK and say yes to override everything and OK, you will see if I hit OK, let it regenerate the toolpath, I don't get any errors, right? So now I have a boring toolbar, but it's not along the z-axis what you wanted. Okay, that's fine. I'm just kind of doing this step by step. So I'm going to edit that toolpath. I'm going to go back into the tool, right click and hit edit. Now I'm back in again. Go to the setup tab, and here I can actually change the direction. So maybe I make it 90, and now I get this. Let's go ahead and notice that we can do tip compensation. We can, on the holder, we can choose behind right and left hand. Let's just hit OK to this, see what we get. That's not right. Uh-oh. Let's go back in, select the tool again, edit the tool. Let's go ahead and change it to a left-handed. Hit OK. Yes. OK. Now we get what we wanted, right? So know that Fusion will let you do a lot of the things that you want, but it just comes down to this methods. For me, at least personally, I prefer to kind of like make a change, check it, make a change, check it. Many times when we go in and do things in here, we get caught up and it sets us down for the next trouble. The other thing I want to show in here, just because that there's a chance that you get thrown up, is now we machined one side. Now we got to do the second side. I'm going to create the second setup. I'm going to change that back to mill turning like we did before and flip the axis. Now I'm literally having a second setup. Hit OK here. Okay. Now I'm going to show you something that you may or may not run into. If I go now head here and do the same thing, let's do a turning profile. We can use the same tool, hit OK. And now we see how we get a turning profile using the same tool. You might be happy with this. You see how this is going around here? What happens with cam turning is that it's actually slicing through our model when it does this. And it was not a problem from this part right here. But let me show you something. Let's go to the top here. If I go back into the design environment and I use the move tool, and I'm literally going to move this body. I'll rotate this body here. There we go. I'm going to rotate this body so these grooves you have here are right in that horizontal, 30 degrees, right in the horizontal. Now when I go back to our cam environment, a manufacturing environment, I got to update my models. Actually, you don't have, if you are happy with the first model, you actually don't have to update it right now. You could just right click on it and you could click protect. I do that many times, so that doesn't mess with. What I want to show here, when I update this model, notice what happens. You see here how it cut into that pocket because it now it's in that cutting band. Fusion has this really cool function in the setup. Right click edit in the setup where you can do what's called a spun profile. And it's actually kind of like looking at it as revolved. We got the body selected. Now I hit OK. And if I update the tool path, see how it got the cuff? You'll see right now, before I update it, it kind of will do this body here. If I right click and I hit generate, now it's back to where it was before we moved it, and nice smooth X's here. So that's a couple of tricks that I hope that you would find helpful for this part here. So a couple of things for you, Paul. Number one, yes, you can absolutely upload your Inventor file. Don't not do that. And two, when you do go in and do your turning, break it down. Hope that was useful. Thumbs down if it wasn't. Comments if you had anything to add. Yeah, subscribe, all that good stuff. Let's jump on here. Next one is also Cam. And this one I'm excited about to show you. This one here comes from Gary. And Gary says, I've been using your tutorials on YouTube to learn Fusion. Thank you. You have great content and excellent teaching skills. I appreciate it. So, I have built my own CNC router, and I'm now using Fusion CAM package for machine tool programming. But I have to say that I'm struggling to get the machine to do what I want. Right? We all do sometimes. So, my current problem is I'm making a spoiled board, what is like something you can drill into large patterns of holes for hold downs. And it's counterbores, and so you build countable holes, but you don't want to go in and select every single hole manually, and you don't want to drill it. You actually want to machine it. So let's go in and look at that. Here we go, Gary. From one cam to another cam. So let's go ahead and draw a spoil board up. Keys and a rectangle. I don't know, we're going to make this 800 by 400 spoil. I don't know what size you're using. Doesn't really matter. Q for press pull. Let's give it a little bit of thickness here. So that's our spoil board. Now, I am going to go ahead and do some patterning, some counterboards. I'm going to show you something I think is funny. I'm going to start offset a sketch from here. I'm going to go in -20. I am going to open a sketch on that plane. P for project. I'm going to steal the edges of these here. And then I'm going to draw half of a counterboard. Boom, boom, boom. Just going to go over here, down. Just make sure I close this up. So I'm making my custom counterboards because I can. D for dimension, and we're gonna make this one 6, and let's make this one 12, and then let's go into solids. Let's go into revolve, and we're gonna select that profile. And we're gonna cut right through that edge. And we just model up a counterboard. Just trying to show you a different way we can do things. All right. So what Gary did was, now where he had his counterboard, however he modeled it in, then he went in and used the rectangular patterns. So we all are familiar with that one. I'm going to go in and select feature. I'm going to select that revolve, and select an edge to do this by. I'm going to do by spacing, and let's make these 25 millimeters apart. And maybe more, let's make them 30 apart. And let's just throw a bunch of them in here. Okay, it's going to take a little time to generate when I do it like this, but that's okay. We're going to go in the separate direction. Over like this. And let's do 3. Let's do 30 both ways. All right. So we have 25, 13, 30, 30. Okay, I'm going to hit OK to this. And it's going to take a second. Or two. There we go. That's a lot of counterbores. All right, so let's get into CAM. I'm going to show you a couple of tricks how we can do this on a CAM. So go into manufacturer. There's a couple of different ways we can do this, Gary, and I'm going to show you both of them. So I'm going to make a setup. That's all good. And you were talking about you wanted to mill this. So I'm going to select the circular tool. Now, let's go in and select the tool. I'm going to select the metric, and I'm going to select a 10 millimeter flat end mill. Okay. And for the geometry, you have two different options. I would probably do this in two operations. I would select this one here. You see how we get our tool path? And then if you hit select the same diameter, boom. Now it's going to find all of them. You can choose the order, how you want to order all of them. Hit OK, and they have now machined all the top of the counterboard. Then this is what I would do. Then I would right click and I would select the duplicate, what gives me just a copy of the first one. I would right click on it, hit edit, and then I'll go into operations and unselect that face and select that face. And then you have all the rest. This is what I would do if I was going to machine this. Select the top, and now it would literally just start machine all the tops like this. And then it will go ahead, when it's done with that, go ahead and select all the bottoms. And I don't know what I selected there in the end. Since, there's probably too big of a lead in, lead out. Whatever. That's one way you can do this. Like this. Let's go ahead and look at that. Oh, that's because it just plunges down. That's fine. That's one way you can do this. The other way you could do this is, let's go back in and edit these toolpath. Let's turn off the select same face, because what I think that Gary maybe want to do is actually machine one at a time. So I broke it down so I would machine all the top of the counterboards, then all the bottom of the counterboards. But of course, if you want to machine both of them in one and then go ahead and do it, well, you can, inside of here, actually also do patterns. So click setup, select, actually no, I think we got to select these two, right click and select add to new pattern. Now you can do a linear pattern just like we just did. So we can select here, remember what the distance was? 30. It's going to be the other direction, flip direction. How many of them did we do? 25, I think. Whoop. Add another direction. What was the spacing? I think that was also 30. Maybe. So that direction there. And did we do 13? Yep. And then down here you can choose to say preserve order, where it will again actually do it what we just saw, or you can say order by operation, I think. Now I can't remember which one it is. Now if we're going to simulate it, counterbore. Oh, that was not it. See how it jumps between the two? Right click edits, preserve order. Maybe it makes more sense. And now it's going to do the counterbore. Then it's going to do the circular hole, counterbore, circular hole, counterbore, circular hole. I think my lead in, lead out is screwing up with that center hole there, but you get the picture. So that's a couple of different ways you can do that, Gary. I hope that was useful. You let me know. All right. Next one here is from Lord. Lord sent me a message. Yeah, I gotta show this one, and this goes back to last week's live stream because a bunch of people reached out to me. So let's just new document here. Remember we did this last one with a twisted steel, and I have gotten some comments and I have gotten some emails, and I am okay with that. Let's get back into the sign. So if you notice, what we did last was we talked about twisting steel. And the way I showed it was to go in and draw an offset plane and put a sketch on that you rotated. And then you draw an offset plane and another sketch and rotate it. I did that one more time and offset that, rotated it. And then I used the loft. And in that way, we got some twisted steel. Now, inside of Fusion, there is 80 different ways of doing it. And yes, there is another way to do it. And let's do that. So if we go in, we open a new sketch. That's using the sweep command. And if we go in and open up a rectangle, let's make it 80 by 80. Here, one sketch. Now, there's something you got to be careful about. And that is where you're placing your next sketch. That is the path. I'm going to go ahead and open a new sketch. And I'm going to place it right here. I'm going to make sure I'm draw from the center. I'm going to hit alpha line. And I'm going to draw a line out here. I'm going to make it, 200 maybe. Okay. 2 sketches. And now if we use this sweep, select that as your profile, select that as your path, everybody's right. There is a twist angle here. And if I go in here and say 180, it will absolutely twist that part there versus my part here. Now, so some people's going to tell me which one is best. And now we can start arguing all we want till we die. I'm not going to argue with you. This thing here is absolutely quicker than this one. Now, this one is not as accurate as this one. This one takes more work. This one is not as accurate. You can actually see kind of like how things are flowing compared to how things are flowing in here. There's a lot more control inside of the loft. And my main reason to pick it, if you should ask me, was that I like the idea of having this control, doing some different offsets and things like that. The reason you gotta watch out with this one is that if we're just going ahead here, you could, in theory, get the same result as you just saw by not using the center. So you gotta make sure you're using the center. If you, let's just delete the sketch. If we decided to, if we decided to open a new sketch and projected this edge here, hit alpha line, let's make that 200. You will now see that I moved the sketch line from the center now. Well, maybe this is what you want. Now, if we're going to sweep this along this path, everything looks the same, and this is the same until we're adding our twist angle, and you will now see it's twisting over that line. So you just gotta be aware of that. 2 different ways to do it. I'm happy to whatever you find useful. That's all I care about. Thank you for all the emails. Thank you for all the comments. I love it. Brad Tallis reached out to me too about it. Yeah, use the one that fits you. Thank you so much. And I was going to show you one thing about Lloyd. He actually sent me another image. Look at what he 3D printed here. Using the web command, the rope command. That's a nice little coaster there. Good job, Lloyd. Oh, I didn't switch it over. I showed you without showing you. That is cheating. There you go. There is his coaster. There you have the web. There you have the rope. Good job. Love it. All right. Let's see if we can't wrap up these with a couple of quick ones. Next one is from Paul. Hey, Paul. I'm brand new to CNC with particular interest in milling. I'm a hobbyist, and I'm currently working my way through Fusion 360 tutorials along with a Mac Free. May I ask if it would be possible for you to send me the model shown in your webinar? So, I just wanted to touch on this because a lot of people is gonna maybe like this or maybe not. I don't know. I have done a lot of videos. I have modeled up a lot of different models in a lot of different live streams, webinars, or whatever. I will be happy to share all my models with you if I can find them because they're not organized. But send me a screenshot. So take whatever webinar you watch, Paul, or whoever else want to get into my models. Send me a screenshot and say, hey, can you send me the model? And I will do my best to get those to you. Next one here is from Stefan. Hi, Lars. Did I ask a wrong question? You didn't reply to my email. Oh, I think you're very busy, but please let me know if you can help me if time allows or you will not. I feel like the Stefan is yelling at me here. You are more than welcome to send me an email, Stefan or everybody else, Lars.Christensen@autodesk.com. I will answer as many questions as I can on these live streams, but I can't answer them all. I do not have time. And if I sat down and was going to reply to you and say I don't have time, then I might as well try to spend the time to answer it. So no, sorry, Stefan, it's not going to happen. But Stefan did ask me a question about what he's struggling with, and that is he's going crazy about moving components parametrically. Generally, I want to design with user parameters to change dimensions easier later. And he's struggling about working with parameters, layout sketches, and how get to things updates. Yes, Stefan, with great power come great responsibilities. This is one of the hardest things to do when it comes to modeling inside of mechanical CAD. Something we all want to do, and it can sometimes go wrong. So start out by test often, and you can normally catch any mistakes when you're doing anything. A couple of videos that I will recommend for you to go and check out in here. If you go to my playlist, because I've talked about this topic a few times. If you go to Make Anything, my latest video down here called Parameter, Joints, and Layout, Sketch, and Glue, Everything in One Box. That is my attempt to talk a little bit about how you can use components, layout sketches, parameters, and I'm even talking about how you can do like even spacing using parameters. So when you're chasing one things updates in here and what you get. So that's the video and then I ended up actually making the box in the end, and I painted and I do all kinds of silly things. Parameters, joints, and layout, sketch, and glue. That is the box. But to anybody who's emailing me, sorry, I can't answer them all. No, sorry, Stefan. Next one here is a quick one from John. John sent me a file. Last week, we 3D printed a towel rack. Mine did not come out great. I should have had the slit going all the way through, and I didn't do that in my model. Actually, I'll show you the model. Now somebody's going to email and says, I want that model. But this was what we did last week. I did this towel holder, and, I printed it, and I should have let that slot going all the way through. That is not what I'm 3D printing right now. Right now, I'm 3D printing the piggy bank that I showed in an earlier live stream. You're going to have to go and check that out. So the towel holder, that didn't work out for me. That needs a little bit of redesign. Let's do one more, and then we're going to call this quits. This one is from Paul, and this is a good one. I have searched for an answer to these questions everywhere. I've ended up having to hire someone because I couldn't working it out. I have a known shape that I have a sculpted handle around. Let me show you what Paul sent. A knife handle. Okay? When you have something known, a knife handle here, and you want to sculpt something around it, how do you, when you have a known face, how the heck do you get to do that? Well, I couldn't help it to do it any other way, Paul, than open up my knife that I modeled up back in one of the last live streams. See that? But let's just delete all this stuff. that was all that. Delete that. So now we end up with kind of what you're having. We're ending up with a somewhat of a given shape that we now have to, we want to use sculpt to kind of create the handles. And that's what we're going to do with this last one here. So we have the known shape, and I actually modeled it up in a couple of different ways. That's why you see the shadow here. I think I'm probably going to get some arrows if I make this. So I modeled up the handle in a couple of different ways. Here it was done without the sculpt, and then the one I just deleted was the sculpt. Okay, how would I do this with the sculpt with known faces? I'm going to go in here, Paul. I'm going to say I'm going to jump into the sculpt environment. I'm going to use this perimeter box here, and I'm actually just going to kind of like draw. It doesn't matter really what plane you're drawing on. Actually, this is kind of crazy. I'm going to draw up something that I think is going to be a hand looking like this. And without exiting out of this, you can actually make some changes over here, which is kind of nice. Now, right now, Paul, what I'm doing here is just kind of taking a piece of clay, not worrying too much about anything at this point. But I can start, of course, working on this. So maybe I'm looking at this and says, I want some different faces in here. That's probably better. But it's out of place. I get that. I'm going to hit OK. Okay. So there we got like a bar of soap or clay or whatever. Let's move it into position. I'm going to highlight the whole thing. I'm going to right click and hit this edit form. Go to my right view. And I don't really want to scale it. I don't want to move it. I'm going to move it and scale it apparently. Scale it up again. I'm going to move this till I think it's somewhat about close to where I think I want to handle one. I actually going a little bit past here. But that's okay. I'm going to place that there. Now, I know a couple of things with these kind of handles. I know that I want symmetry. I talked about that before, so I'm going to click here and click symmetry. I'm going to select them two faces up here, and that gives me this green line. That means anything I'm doing on this face will now also go on this face. What I mean by that is that if we now go ahead and select, let's hold down Control and select 4 squares, right-click and hit Edit. If I pull in this handle, you will see that it's symmetrical. It pulls here. Okay? So you could start forming this handle now at whatever kind of shape you would like to do this knife handle in. And that really, of course, comes down to a lot of different things. And I will tell you that the more, and I say this every time, but I'm going to keep on saying it, the more time you're spending working in here with your shape, the more you're going to get something closer to what you want. And all this stuff is all part of interpretation. It's all about what you think could be a cool shape, could be a cool thing for you to kind of work with. However, what you think would fit very well for your knife. Okay, so you shape this. This is not the prettiest knife handle I probably have created, but you will see how, I hope that this somewhat makes sense, how I kind of like, working with this in whatever kind of shape I maybe want. Then I can select points. I can actually also select lines. You saw here, I can select this line here instead of a point if I wanted to kind of try to create somewhere where my hand, this is all about making it as good as you want. When you're done with this, when you've gotten this where you think it's close, you hit finish form and you now have this solid. Now I'm going to show you a couple of tricks. One, this is now 2 solids. It is our knife handle, I haven't changed, and it's our body in here. You could now go in and do something like split body. I could select split body. Body to split is the handle that I made too far. And I could use this face right here as my cutting. If I do that and hit OK, now you will see it end up with 3 bodies. This body 5 is actually kind of top here, if I right click on that, hit remove, now I just made this body completely flush with this plane. That's pretty good. The other thing I'm going to show you, and I've talked about this tool before, is the combine tool. If I select the combine tool, I select the target body as my handle. The tool body is the knife that has that bar going in there. Now if I select cut, and I'm going to say I'm going to keep the tool, what is the knife handle, hit OK. Nothing happened until I hide the knife handle, and you will now see I got a perfect shape in there of that goes in there. Last thing I'm going to do, let me hide the knife handle again. I could go in and use this split body again, and maybe turn my origin on. I could select that body and split it with the plane. And if I'm going too fast, Paul, rewind back, see the clicks, watch it a few times. Now suddenly I've broken this down to a couple of different ones. I can now go in and sketch a circle for the screw hole or whatever I kind of want in here. I hope this gives you a little bit of a better idea about how you can take something organic, you can take something like a knife that you already know, and you can turn this in to something that is worth doing yourself. Paul, I hope that was useful. If you like that, thumbs up. If you do not, thumbs down is okay. Leave me in the comments, and if you haven't subscribed, I really appreciate it. Folks, that is it for this Sunday edition of Ask Lars Live. Hope you found this useful. I'm just trying to add some value. And until the next time, I hope you have an awesome, awesome day. Take care, folks.